Linear equations are everywhere. The parent function for linear equations is y equals x. So anything y equals x is the same thing. The domain of a linear function is infinity to a negative infinity, aka all real numbers could be the possible value for x. The range of a linear function is the same thing, infinity to negative infinity, aka all real numbers could be the possible value for y.
Now, for continuity, the easiest way to explain what continuity is if you take your pencil and you have a graph, can you draw that graph without picking up your pencil? If you can, then the function has continuity. As you can see, a linear function, because you just draw a line, has continuity. A parabolic function could also have continuity. Almost all functions have continuity. So for any behavior, when x is going to positive infinity, y will be going to positive infinity. But also, it's possible that if x is going to negative infinity, y could still be going to positive infinity, as you can see here on this graph.
Okay, so an even function is where the line of symmetry is down the y-axis. So on the left, the quadratic function y equals x squared is symmetrical to the y-axis, approximately. For odd functions, it's symmetrical in respect to the origin. So if you would rotate it 180 degrees, it'd be symmetrical to, or it'd be the exact same to where it started.
Okay, so for line of symmetry, for y equals x is going to be pretty easy to understand the line of symmetry because y will equal 0 and x will equal 0. And a line of symmetry is when the function is divided equally in half. As you can see, a reflection for a linear function is also very simple because the red line is the original parent function, which is y equals x, and a reflection is just when you move it along either the x or y axis, and in this case, if you move it along either the x or y axis, it's still going to end up as a negative, as it being y equals negative x, so it would be what the green line looks like. So it wouldn't be that difficult to do a reflection with a linear function. So when it comes to shrinking and stretching a function, for linear function also, as everything else, wouldn't be as difficult because all you do is you just do something to the line. So for example, the red line is y equals 1/2 x, which makes it shrink, so it makes it the slope steeper on the graph, while the green line is 3x, which makes the slope a little wider and a little larger, so that would be the difference between shrink and stretch, is making the slope different and resulting in a different type of line. So a transformation is pretty easy to explain. It means that whenever a line does not change its shape or size, it just moves somewhere on the graph. So for example, moving from the parent function, which is y equal x, we moved 3 up, so now it's y equals x plus 3. Having a transformation but not changing the shape or size of the function.